Hey everybody, today I'm going to be proving the product rule of differentiation. And so if you need a refresher, this is what it is. We're going to be proving it using the limit definition of a derivative. So, let's get started because this is going to be a pretty long video. And I think there are going to be parts where I'll have to speed up the video because this is going to take up like the whole board, at least lengthwise. Like there are parts where it's going to take up a long space. But let's just get started. So basically, the limit definition of a derivative is limit as h approaches 0 of f of x plus h minus f of x all over h. Here, our function is going to be f of x times g of x. So let's just write that down. So limit as h approaches 0, right? Always do that. And I'm going to make sure to try to write it kind of big, but I'm going to have to limit spaces somewhere. So yeah, f of x times g of x, so f of x plus h times g of x plus h, right? And so then this is going to be minus f of x times g of x all over h, right? So this is just our limit definition of a derivative, nothing too special there. So now what we're going to do is we're going to add and subtract a term, okay? So what it's going to be is the limit h approaches 0, we still have our f of x plus h times g of x plus h. Okay, but now we're going to subtract f of x plus h times g of x. And then what we're going to do is we can't just just subtract this out of nowhere. We have to add it back, right? So plus, let me make that clearer, plus f of x plus h times g of x, right? And then obviously we have to subtract our f of x times g of x like we had earlier, right? And this whole thing is divided by h. So, all right, all divided by h, okay? So now what we can do is we can notice, well, we can split this limit up because, actually, no, let's not do that first. Let's notice that we can factor out an f of x plus h from here and here, and we can factor out a g of x from here and here. So let's just do that. So let me just write it. Limit as h approaches 0. So from the top, we're going to take out an f of x plus h, so f of x plus h, okay, and then we're going to multiply that by g of x plus h minus g of x plus h minus g of x. And I think here, this is a good place, we can just divide this by h, right? And so a property of limits is that you can take the limit of each individual part, and I chose to take the limit of this part, which was these first two terms, divide that by h. And then, because what I'm doing here is I'm taking this h, dividing it there, and just, doing it like this, right? And so the limit of this is the limit of this, which is this, plus the limit of that. So we can take this part, and then we can tack it onto the limit. Same thing, limit as h approaches 0. We're kind of like, you can think of it as distributing the limit now. And we're going to factor g of x out of here. So g of x, okay, multiplied by f of x plus h minus f of x divided by h. I'll actually close the parentheses there. Okay, so now we have two limits here, okay? Two different limits. So what we're going to do is, well, we can actually notice that whenever we divide by h, by the whole thing, we can actually kind of just like think of it like this, divided by h. So that times that, right? And then this same thing can go here, and we're doing this over that. Notice this, and notice that. This is pretty cool, right? So a cool thing here is g of x, we can factor it out of the limit because it doesn't have anything to do with the h's. It doesn't have any h's, and it's just multiplying by this. So technically, in terms of the limit, it's just a constant multiple. So we can swap these two places around, right? So let me just make this clear. Let me put the parentheses there. So this is plus g of x times the limit as h approaches 0. What is this? This is just f prime of x, right? So we can replace this. I'm going to use a red marker here. So this is just f prime of x. So that is really cool. Now, unfortunately, we can't do the same thing here. We have to, because f of x plus h, we have to actually work with this. Now, how are we going to get that to happen? So what you can do is you can just, really another thing you can do is you can just multiply things like this. You can multiply limits. So we can do the limit of, so okay, hold on. So the limit of two things being multiplied is the limit of this times the limit of that. So that really helps us because now we can just say lim h approaches 0 of f of x plus h, right? Now we're going to multiply that. Let me make that a little clearer. We're going to multiply that by the limit as h approaches 0 of g of x plus h minus g of x over h, okay? And then we're just going to add that on to plus our g of x times f prime of x, which is what we found up here, okay? So this, as h approaches 0, this is going to be f of x plus 0, which is just f of x, right? So once we evaluate this limit, this is just going to be equal to, let me put it over here, right? So this is going to be equal to f of x, okay? Limit this, again, is just g prime of x, right? G of x plus h minus g of x over h. This whole thing here is g prime of x. So we can just substitute that in here. So times our g prime of x, and then we can just add it to what we found earlier, g of x times f prime of x. And here you can see, if we don't really, doesn't matter about the multiplication symbol there or not. Here we can literally see this is just that. So once we evaluated this using many different properties of limits, being able to split up addition or multiplication, or recognizing that these are derivatives, once we do all of that, we end up with our desired result. So using the limit definition of a derivative, we found that the definition of a product, a derivative of a product, is defined to just be this formula, and I think that's really cool. In a future video, I'm going to derive the quotient rule of differentiation using a similar way. I've also derived it in the past. I can link that video if you want, and then once I upload the actual other quotient rule of differentiation video, I will link that as well. So yeah, thanks for watching, and I will see you all later. Bye guys.